Let's find the Young's modulus for this material. Now, as we're looking at what we have here is we have a stress-strain diagram, and this definitely appears, looks like something more of an aluminum, and the reason I can tell that is you can see that it goes right into strain hardening here. There is no perfectly plastic region, and that's fine. So as I look at this, this is given to me in metric units, and I can tell because stress is in megapascal, strain is in meters per meter. So I want to find E. Well, how do we find E? Well, E is the slope of the line. Now, if I take my Young's equation and write normal stress is the Young's modulus times the strain, it's like, oh, well, I can just rewrite this as simply the stress over the strain. Now, you can do that at one point. The problem is this is not as accurate as it could be, because you're finding it at one point, and there's always little variations in the point. What you want to do is you always want to find the slope of this line. The slope is going to give you the most accurate strain available. Excuse me, the most accurate Young's modulus available. So what you want to do is for a slope, you want to capture as many points as you can. So how do we find the slope? Well, the slope is the rise over the run. So what we're going to do is we're going to take the Young's modulus, we're going to take stress at point 2 minus the stress at point 1, strain at point 2 minus the strain at point 1. Now the thing is, we're going to be able to use that point 1 as 0, 0. So that'll make things a little bit easier. So what I want to do is I want to go up as high into the line as I can without going over the proportional limit. So what I'm going to do is I'm going to go here at 400 megapascals of stress, and I'm going to drop this down here, and this looks to be about 0.005 meter per meter. So we're going to come over here and go, our stress is 400 megapascal, so 400 e to the 6 pascal. We're going to divide that by 0.005 meter per meter. Now this is really minus 0 because we're going back to the 0.00. If I throw that into my calculator, what do I have? I have 8 e to the 10 pascal. So e to the 9 would be gigapascal. So this is 80 gigapascal is our E value. And that's a pretty typical E value for a metal material.